Hello, welcome back to the Chong channel. Today we will be dealing with density of a sphere question on the August 2018 number 34 Regents question. So let's take a look. A bakery sells hollow chocolate spheres. The larger diameter of each sphere is 4 centimeters. The thickness of the chocolate of each sphere is 0.5 centimeters. So if you look at the picture so far, unfortunately, I can't really draw this in 3D, but if I were to cut that chocolate sphere like in half, this would be the flat version of what we see, right? So this would be the whole chocolate. And so I drew the outer part, that's the whole chocolate sphere. And then it says the diameter is 4 centimeters. We know if the diameter is 4 centimeters, then that means the radius is 2 centimeters. Now the thickness of the chocolate, so here, the thickness of the chocolate, the black part here, of each sphere is 0.5 centimeters. So now I drew the inner part, so this would be the hollow part, the empty part. That would be green. So this is what I labeled as inner hollow part of the sphere. So if I said the radius is 2, so this whole part is 2. Now the black part, which is the chocolate part, that's the thickness, and they said it's 0.5. So if I wanted to find the green inner part, it would be 2, so this whole thing 2, minus the thickness, 0.5, equals 1.5 centimeters. All right, so now here it says, determine and state to the nearest tenth of a cubic centimeter the amount of chocolate in each hollow sphere. Now, one thing you need to understand, when they say cubic centimeter, that's giving us some clues. This means it's going to be volume. So here we know that we're going to look at the volume of a sphere. Now this question is kind of tricky. Everyone should understand that hollow means empty. So usually when you get chocolate, the whole chocolate is full of chocolate, but in here it's going to be empty inside, and this is empty. I colored in green. So what we're going to do is I copy down from the Regents formula sheet the volume of a sphere, and it's 4/3 pi r cubed. So first we're going to find the volume of the whole chocolate sphere as if I took it as the whole thing here. I plugged in the radius is 2 into the formula, and I put pi in the calculator, and this is the decimal we got. Keeping in mind the units for the volume is cubic centimeters, okay? So now look here, we did the same thing for the hollow part. So the hollow part is this green circle here, and I copied down the formula as you see, and in this case the radius was 1.5. Once again, it was 2 minus the thickness 0.5 gave us 1.5. So when we plug that into the radius, this is the volume we got. So keep in mind that fractions, you put parentheses, pi, and then the radius cube. Now, remember, we have the whole chocolate, which we colored in pink. So if I wanted to find the amount of chocolate in each hollow sphere, it really means the whole chocolate sphere subtract the volume of the inner hollow part. So what I did was I plugged in the whole chocolate sphere volume, subtract the inner part of the hollow chocolate sphere, and then we get this decimal. Remember in the problem, it told us to round to the nearest tenth, and so we underlined the tenth place. Look at the next number. That number is 5 or more, so this becomes 19.4 cubic centimeters. Now, if this was the Regents question, I mean, that was tricky in itself. It would seem not too bad, but there's a second part to it. So this is where we see the density part to the question. Now, one thing you need to remember, okay, so first let's read the problem. The bakery packages 8 of them in a box. So remember, anything we found before, that was just talking about one chocolate sphere. But the bakery packages 8 of them, so we have to keep that in consideration later. Density of the chocolate is this amount of grams per cubic centimeters. And it wants us to determine and state to the nearest gram means whole number, the total mass of the chocolate in the box. First of all, the formula that you need to remember is density equals mass over volume. But if you remember, we wanted to find mass. So if we did some algebra here, I want the red mass. So if this is divide, the opposite is multiply. So we're going to multiply both sides by volume, which means I cancel this and I got mass equals volume times density. So what I did was I copied down the volume we got from the whole section we did above here. Our volume was 19.4 cubic centimeters. And remember, that's for one chocolate. I copied down the units. The density they gave us in the problem was 1.308 gram per cubic centimeters. We plug that in. Now remember, cubic centimeters, they cancel. So when I multiply these two numbers, this is the decimal we got, and that's in grams. But keep in mind, this is the mass of one chocolate sphere. But how many were in a box? They put 8. So we got to multiply this mass by 8. And so we got this decimal. The question told us they want us to round to the nearest gram. So nearest gram means whole number. So that would be 203 grams is the total mass of the chocolates in the box. That was pretty intense. I hope that helped. And today our visitor was Señora Coneja.